Overall, the tests were actually pretty good. So 5.1 is called exponential functions and their graphs. Okay, start with what is an exponential function, and an exponential function has a base. In this case, it's a, and then it has an exponent. Okay, an exponential function has some sort of variable in one of the exponents or multiple exponents. Okay, so you'll always see like an x in the top, you'll see a y, you'll see an a, whatever it is. That will be the exponent of it. So if we're using terminology on this, the a is called the base, and the the x is called the exponent. It's a function, so you'll see f of x, you could also see y there, and that's the same thing, okay? A will be greater than 1. So what you're raising to a power will be greater than 0. And it won't be 1. If it was 1, no matter what I raise it to, it stays constant. That's a line, and that's an exponential function. So it will be something that either increases or decreases as you move through. When we graph an exponential function, there's kind of two kinds. One is that increases as you move from left to right. So it's something like this, okay? It kind of starts out a little flatter, and then it has a steep climb on it. That steepness will change, okay? It could grow faster or slower, flatten out a little bit, but it will always have that kind of a curve to it. So you're not looking at a line this time. You're not looking at a parabola or a hyperbola, nothing like that. These have a curve to them. This would be if b, which is the base on this one, is bigger than 1. So if I'm raising something like f of x equals 3 to the x, or 4 to the x, or 5 to the x, or 6 to the x, and so on and so forth, it's going to increase as you move from left to right. If the base is a fraction in between 0 and 1, then it falls as you move to the right. So it decreases. And this would be something like 1/2 to the x, or 3/4 to the x, or even a decimal, 0.5 to the x. Okay? Those are going to fall as you move from left to right. On the parent functions, like the ones you see here where there's no shifts, you're always going to have a y-intercept at 0, 1. And you're always going to have a coordinate at 1 and then whatever the base is. So 1 comma b. We are going to shift these though. We're going to move them right, left, up, down, all that stuff that we're used to shifting of the graphs. The domain of these is all real numbers. So notice that my arrows point both left and right. So my domain is going to be all real numbers. The range of the parent function is going to be 0 to positive infinity. So it's going to get as close to that x-axis as it possibly can without touching it. And this is again of the parent function. As soon as we shift our graph up and down, that changes. The domain won't change, but the range will change. So if you want to give yourself a little reminder, this shifts or changes with a vertical shift. Or reflection. Because if this flips upside down, obviously my range changes too. So remember, domain is your x values and range is your y values. To note is that there's arrows on both edges, right? So these arrows mean that this graph continues on in both directions. When you graph these exponential functions, they should do the same. You should have arrows on both sides.
What does it say under vertical shift?
Or reflection. So most of these, we start with our typical way of starting, our basic foundation of starting graphs, and that is the T-chart. So I'm going to take something like number 1, and it just says to graph it. I'm going to draw my T-chart. Actually, it doesn't matter if you do it vertical or horizontal, however you want to do it. -1, 0, 1, or -1, 0, 1, whatever you want to do, okay? And I'm going to take those points and I'm going to plug them in one at a time. So I'm going to take my graph that's here. I'm going to change the f of x to y. So y equals 2 to the negative 1. And then I'm going to do it again. Y equals 2 to the 0. And then I'm going to do it again. Y equals 2 to the first. So what does the negative exponent do to that 2? Good. Moves it into the denominator so it becomes a fraction. So when x is 1, negative 1, sorry, y is a half. What is 2 to the 0? 1. Anything raised to the 0 power is 1. And what is 2 to the first? 2. So I'm going to take and plot those 3 points. Negative 1 and 1/2. 0 and 1. 1 and 2. I know it's going to get as close to that x-axis as it possibly can. And then I know it's going to point up to the right-hand side. And my graph will approximately be that. So 3 points should be exact, but how fast you climb after that doesn't have to be perfect. Now, if I ask for domain of this function, you tell me it's negative infinity to positive infinity, and that's because the arrows point left and right, and also because every exponential function has that domain. The range would start at 0 and point up. So it'd be from 0 to positive infinity. It doesn't touch the x-axis, so it gets a parentheses and not a bracket.
Why does it start at 0?
Because it's going to get as close to that axis as it possibly can, but it's never going to touch it. I can't say 0.999999999, right? Or 0.00000000000000001. I say 0, but don't include 0. So it's going to get as close to 0 as it can, but it's not going to touch it.
What's the range again?
Bottom to top.
So that would be like half or like.
Because it's going to keep going lower. So the further it gets over here, the closer it gets to that x-axis.
Oh.
Does that make sense? Like if I plugged in negative 100, I'd get a number. It'd be teeny tiny, but I'd get a number. I can go past that 1/2. Does that make sense? Yeah. And then if I wanted the y-intercept, it would be at 0, 1. When I plug in 0 for x, what do I get? It's usually the middle term on your T-chart, okay? But it's also where it crosses the x-axis or the y-axis. And what's happening here is there's actually an asymptote, okay? There's an asymptote that's running through the x-axis. So there is a horizontal asymptote. At y equals 0. And that's why it can never touch that. Because I can never get this graph to be 0. Nothing raised to a power can never be 0. All right, now we're going to do 3 to the x. So 3 to the x, I'm going to start the same way. I'm going to do T-chart. I'll do it this way now. It doesn't matter which direction, your preference. If I plug in negative 1, what's 3 to the negative 1? 1/3. If I plug in 0, 1. If I plug in 1, 3. So negative 1, 1/3, 0, 1, 1, 3. So my graph appears to be similar. It has that increasing behavior. My points are similar, not exactly the same, but everything else is exactly the same. The domain is negative infinity to positive infinity because it points from left to right. The range is 0 to positive infinity because it gets to that axis but can't touch it. The y-intercept is 0, 1 because when I plug 0 in, I get a 1. And there's an asymptote at y equals 0. All right, so what happens when you plug in negative 1? 1/10. 0. 1, 1, 10. Good. So it gets closer to the x-axis, but like the comparison of a graph of a 1/3 to a 1/10, I don't stress about. I'm not going to take out a little thing and measure that you're 1/10 away. Okay. Then the 0, 1 should be on there, and then the 1, 2, 4, 6, 8, 10, all the way up here. So it gets, again, as close to the y-axis as it can, or the x-axis as it can without touching. This time it grows faster. So the faster the base, the steeper that line is. Okay. Domain is what? Negative infinity to positive infinity. Range 0 to positive infinity. X or y-intercept 0, 1, and horizontal intercept y equals 0. Good. Okay, so now 4 changes how? It's a fraction. So we said two things happen when it's a fraction, right? Well, not two things. One major thing is that it decreases now, and so it's going to start up and it's going to fall to the left. You'll see that if you plug in points. So if I plug in my points, same ones, -1, 0, and 1, and I did a half to the -1, and then a half to the 0, and then a half to the 1. So now the number's not in the top and it gets brought to the bottom with the negative. Now the negative exponent takes that 2 and brings it to the top, right? So this becomes 2, this is 1, and this stays 1/2. So -1, 2, 0, 1, 1 and a half. And it starts low to the right this time and increases to the left. Does that change my domain? Nope, still negative infinity, positive infinity. Does it change my range? Nope, still 0 to positive infinity. Does it change my y-intercept? Nope, still 0, 1. How about my horizontal asymptote? No, still y equals 0. So the only thing it changes is that instead of increasing, now it's decreasing. So by it going from a whole number to a fraction, it just shifts the increasing, decreasing behavior. All right, so what happens when we raise 1/4 to the -1? 4, 0, 1, and 1. Good. So -1, 4, 0, 1, and 1 and 1/4. Okay. And then everything's the same again, right? Domain negative infinity to positive infinity. Range 0 to positive infinity. At y-intercept 0, 1. And horizontal asymptote at y equals 0. Everything's the same. Okay? Do you need me to do the next example, or we can save that for tomorrow for review? Save it for tomorrow? Yeah, okay. So we're going to come back to 6 tomorrow. So what's going to happen now is the negative is going to travel to the exponent. So what happens when I put a negative in an exponent and I go to put a negative in there? It's going to cancel it out. So there's actually 2 ways to look at these. One is make that a 1/2 to the x, because that's what the negative would do on that exponent. The other way to do it is just take and simplify every time you plug in. So this is going to be a 2 to the -1. This is going to be a 2 to the -0. And this is going to be a 2 to the -1. So the -1 becomes 2 to the first, which is 2. 2 to the -0 just goes to 2 to the 0, which is 1. And 2 to the -1 becomes 1/2. So I get 2, 1, and 1/2. -1 and 2, 0 and 1, 1 and a half. So even though the base is a whole number, it takes on the pattern of a fraction because the variable has an a negative in the exponent. Okay? If I had just said 2 to the negative, it means this is the same thing as doing 1/2 to the x. So you could have also done that. It's the same thing. Okay? You can only do that if that's the only transformation on your exponent, but you can also treat it like that. So everything else still the same, right? Domain still the same, range still the same, y-intercept still the same, horizontal asymptote still the same. Is that the same thing that's happening on 8? No. Now it's -3 to the x. So I'm going to do -1, 0, and 1. Now this is where we get to be really careful, because that x or that negative is not in parentheses with the 3. I'm not raising a negative 3 to a power. I'm raising a 3 to a power and then making it negative. So it's like doing 3 negative times 3 to the negative 1, negative times 3 to the 0, and a negative times 3 to the first. So I get negative, this becomes 1/3, sorry, negative 1/3. This becomes 1, negative 1, and this stays 3, negative 3. Now it doesn't really matter where we put the negative on what we just plugged in, but if we had plugged in, let's say we plugged in a 2. If you do negative 3 to the second, this is wrong. You have to be careful. It's negative 3 to the second, like that. So that would be negative 9. So it matters when you do those even powers. It's not going to matter on the odd power. It's not going to matter on the 0, but it does matter on the even power, so be careful. And that's why in the beginning, I don't know if you remember, but we said B can't be 0. I mean, B can't be, whatever the base is, can't be negative. We're not saying the base is negative. We're taking a negative 1 and we're multiplying it by a positive base. Does that make sense? That's why it's different. So now this becomes negative 1 to the and negative 1/3. So we're underneath the line now. 0 and negative 1, and 1, negative 3. And then we have it, so I might as well plot that negative 9, but if you didn't have it, it's still okay. Now, it's getting as close to this side of my x-axis as possible without touching it. And then it's going to point downward. So this negative on the front took my graph and flipped it upside down like every other negative we do on every other graph. If you think about our parabolas, if we put a negative in front, it flips it upside down, right? It's the same case here. Absolute value, put a negative in the front, flipped it upside down. Square root, flipped it upside down. You put a negative in the front, it's going to flip it upside down, okay? Now things change. Does the domain change? No. Still negative infinity to positive infinity. What's my range? Good. Negative infinity to 0. So it's pointing down. It's rising this time from the bottom up. What's my y-intercept? 0, negative 1, which I can either get from the graph or from my coordinate point. The asymptote is the same. So the horizontal asymptote is y equals 0. Questions so far? All right, so then we get to the transformations. Everything that's true about every other graph carries over onto this. If there is a number added or subtracted after the function, so not in the exponent, but after the function, it's just like outside the parentheses, right? This shifts my graph either up or down. If it's positive, it shifts it up. If it's negative, it shifts it down. This will change the horizontal asymptote. It will change the range, and the y-intercept will all of it will get shifted because there is literally a vertical shift going down or up, okay? And I'll show you how to find those, but it will change those. They're no longer at 0 or 1. The horizontal translation comes if it happens inside the exponent, just like it would if it was inside the parentheses. So if it's inside the exponent, it's the opposite direction. Remember, if it was inside the parentheses, it was the opposite direction. Same thing here. If I add, then I shift to the left. If I subtract, then I shift to the right. The negative on the front is my flip over the x-axis or upside down, like we just did. The negative in the exponent shifts it over the y-axis. So instead of going up and to the right, it goes up to the left, which we have already done because we graphed a negative exponent, right? The positive went like this, and the negative goes like this. And then if there's a number on the front, it causes a vertical stretch or shrink. Think the bigger that number, the faster it climbs, so it's steeper. So if it was bigger than 1, like if it was 10, if we doubled the base, okay, then it's a vertical stretch. If it's in between 0 and 1, it's a vertical shrink. So a fraction flattens it out. And then the last one is if there's something in the exponent, and this is a horizontal stretch or horizontal shrink. If it's in there and it's in between and it's bigger than 1, it's a horizontal shrink. If you could picture the walls caving in on something, it would still just make it be more narrow. And if it's in between 0 and 1, then it's a horizontal stretch. So for the most part, when you plug in your points, it's going to take care of all this stuff. You just got to be aware of how it's going to affect your asymptotes and that kind of stuff. A vertical shift up and down moves everything. So it's going to shift your domain. I mean, not your domain, sorry. It's going to shift your range. It's going to move your horizontal asymptote. It's going to move your y-intercept. A horizontal shift, I move it side to side. It's going to change my y-intercept, but it's not going to change my horizontal asymptote, and it's not going to change my range. Does that make sense? If I literally just slide it left to right, my asymptote stays at 0. As soon as I start to move it up or down, that's when it shifts. All right, so before we even start to plot these, what do I know about this graph? It's a shift down 2 places. So we have already graphed 3 to the x. Our coordinate points were 1/3, 1, and 3. So I could literally take that graph, if I already had it, and shift everything down 2 places. I'm going to take this little dot. I'm going to go 1, 2. Now that's my new dot. I'm going to take this little dot, 1, 2. I'm going to take this little dot, 1, 2, and I'm going to connect those points. And this is the graph of my answer. The other way to do it is literally plot your points with your new coordinates. -1, 0, 1. So I would do 3 to the -1 minus 2. Then I would do 3 to the 0 minus 2. Then I would do 3 to the first minus 2. What's 3 to the -1? 1/3. 1/3 minus 2 is -1 and 2/3. 3 to the 0, 1. Minus 2, -1. 3 to the first, 3. Minus 2, 1. And then I could have plotted those points. -1, 1 and 2/3, -1 and 2/3, 0, -1, and 1, 1. And again, the red one is all I want for my answer. So this is not part of my answer. It just got us there. So I would say you have choices. If you already graphed 3 to the x and you want to just shift it down, that's faster. If you're going from scratch and you have to graph them, you're going to plug in those points. Now, what's the domain of this graph? Negative infinity to positive infinity. What's the range of this graph? I took that range that's normally 0 and I shifted it down how many places? Good. I shifted it down 2 places, so it's -2 to infinity. And that's because that horizontal asymptote that was at 0 just got shifted down 2 places, right? My horizontal asymptote just went to y equals -2. Y-intercept is where?
0, -1.
Good. All right, so what's going to happen with 10? Sure. What happens when I subtract in the exponent?
You shift right.
Shifts it right. So I could, again, if I already had the parent function, which was here, here, and here, I could shift everything to the right 2 places. 1, 2, 1, 2, 1, 2, and draw my new graph, erasing the old one. Or I can plug those points in. So 3 to the negative 1 minus 2, 3 to the 0 minus 2, and 3 to the first minus 2, or 1 minus 2. So this is 3 to the negative 3. 3 times 3 times 3 is 27, but it's in the denominator. So this becomes 1/27. 3 to the 0 minus 2 is 3 to the negative 2, and that's 1/9. 3 to the negative 1 is 1/3. So I'd get negative 1 to the 1/27, 0 to the 1/9, and 1 to the 1/3. So what happens with this one is all those points stay here. And I don't get that full curve. So you got to be careful with your horizontal shift. You got to know that it's going to climb. So even if I only had these 3 points, I would know I have to turn it up. You can't leave it like a flat line. So domain, still negative infinity to positive infinity. Range, this time is still 0 to positive infinity because there's no vertical shift. Horizontal asymptote is still at 0 because there's no vertical shift. My y-intercept this time shifted. It's 0 and 1/9. So 14 has a little e, okay? That is not a variable. E is called the natural base. So e is like pi. Wait for it. It is an irrational number. It does not end and it doesn't repeat. We approximate it as 2.7. If we need to graph it without a calculator, we go further and approximate it like a 3 if you're going to graph it. Okay, a little bit smaller than 3. So e to the first is 2.7. Which means it's going to have all the same characteristics. Madison, are you with us at all today? Yeah. It's going to have all the characteristics of the graph of 3 to the x. Except the points are just going to be a little bit different. Okay? So this is pretty darn similar to 3 to the x. So on if you have a graphing utility, the E is above the LN button. It's on the left-hand side. It's 3 buttons up all the way on the left-hand side. If you have a scientific calculator, there should be the same thing. It should be an LN button. I just don't know exactly where it is. There's an LN button, 2 down from the yellow second button, and above that is your E to the x, okay? So I know just by looking at this, because it's just e to the x, that's like a 3 to the x, that my domain is 0 to 0, is negative infinity to positive infinity. My range is 0. My horizontal asymptote is 0. And my y-intercept is 0, 1. I know that all because there's no shifts on that, okay? But if I actually am to find some points, let's say it says find them and round to the nearest tenth, I would do e to the negative 1, e to the 0, and e to the first. We already know 2 of those. E to the 0 is what? 1. E to the first is what? 2.7, because we're going to round it to the nearest tenth. E to the negative 1 should be pretty close to 1/3, right? Because it would be like 1/3. But if I do e to the negative 1 on my calculator, I get 0.36, so it's like a 0.4. It's a little bit bigger than a 0.3. So on that one, you have to do negative 1, and then you have to do second ln.
Okay.
So if,
Find it on my calculator.
let me see. Oh, wow. Okay. I was like, you have to have it because we need to check it. So there's a little thing that says log there. If you go second log, we're actually going to do these soon, but under the LN, there's an E.
Oh.
And there's a reason, we'll get to it when we get to ln, we're not there yet, but you'll know why that's there. So you have to go to second log and then go over to the ln. So now I'm going to plot these points, -1, 0.4, 0, 1, and 1, and 2.7, so pretty close to the 3, but not exactly the same thing. And all the same is true. Domain, negative infinity to positive infinity. Range, 0 to positive infinity. Horizontal asymptote, y equals 0. And y-intercept, 0, 1. So there will be questions in the homework that have e's in them, that maybe there's a shift in those. You're going to want to plug those in with your calculator and do them. Just know that you can do this without the calculator because you can approximate e to be like that 2.7. And then it makes it doable without the calculator.
So the calculator's not completely necessary.
For this, no, yeah. Once we start doing like e to the x minus 2 and you have to do e to a negative something that's bigger than 1, then you want to use that calculator. But for the rest of it, you don't need it. So I put the instructions right on the assignment that you better show your work for your graphs, but I want to reiterate it. Like, this is a multiple choice on WebAssign. This will not be multiple choice on your test. You're going to have to graph it by hand. So you want to make sure you do all the things that we just did and then pick your graphs. I will be looking for the work for the graphs in order to get the full credit from the homework, okay? But the actual graph part on WebAssign is multiple choice.
Do we have to put